Hello friends and my dear students, I welcome you all to my channel. This video is part of the playlist CBSE Mathematics Class 7 following the textbook of author R.S. Aggarwal. In this video, I will solve the test paper 5, which is the test paper on the chapter Exponents given at the end of the chapter Exponents in the textbook of author R.S. Aggarwal. I will try to solve the test paper in 30 minutes. I'm not sure if I can do that, but I will give a try. And uh, while solving the while giving the test paper, I will also explain the concepts that has been used. So uh, let's get started with the video. Okay, so I have the timer set. As of now, it is showing 47 hours left, but I will try to uh, solve it in 30 minutes. There are 14 questions. There are not many questions. I should be able to solve it in 30 minutes. So let's start. So this is test paper 5 of the chapter Exponents. So section A, question number 1, write the reciprocal of. Okay, it is asking to write the reciprocal of 2 by 3 whole to the power 4. So reciprocal will be 2 by 3 whole to the power 4. Its reciprocal will be this to the power minus 1, and this is nothing but 3 by 2 whole to the power 4. And okay, so this is not MCQ, so we have to find the answer. Now this is the answer. So what concept we applied? We know that a reciprocal of a rational number a by b, in short writing reciprocal means r, is a by, the notation is a by b minus to the power minus 1. This is nothing but b by a. This is nothing but b by a. Now if you have something like a by b raised to the power m, and then the reciprocal of this exponential number is nothing but we raise this exponential number again to the power minus 1. This is a by b. We know that the power gets multiplied minus m, and we have studied while studying the laws of exponents that this is nothing but b by a whole to the power m. So that is exactly what we did. So 2 by 3 to the power 4, its reciprocal is 3 by 2 raised to the power 3 by 2 raised to the power 4. Now we can break it up. We can express it as in the rational form, in the rational number. This is 3 by 3 to the power 4 divided by 2 to the power 4, and this is 3 to the power 4 is 81 by this is 2 to the power 4. So this is 2 to the power 4. 2 to the power 4 is how much? 64. So this is the answer. 4. 2 to the power 4 is 64 or 16. This is 16, I think. This is 16, and 3 to the power 4 is 9 into 9, 81. Yeah, this is fine. So 81 by 16 is the answer. Okay. Part 2 is minus 3 by 5 whole to the power, what is that? What is that? 61. My God. Okay. So minus 3 by 5 whole to the power 61. This is 61. The reciprocal of this is nothing but we just have to this is nothing but the reciprocal of the base, that is 5 by minus 3, and this is power 61. Now the base, the rational number 5 by minus 3 is not in standard form. We have to make the denominator positive. So this becomes minus 5 by 3 raised to the power 61. This is the answer. Okay. So part 3. I should be able to complete the test when the timer will be showing roughly how much, like 35 or 37 minutes, 17 minutes left. Let's see. So 2 to the power 5 now. Okay. So minded, we are actually, this is not equals to minus, this is reciprocal. We are finding the reciprocal. So these are all, this is fine. Now the reciprocal by arrow, and above the arrow I am writing R, which means I am shorthand. In shorthand I am writing, we are finding the reciprocal of 2 to the power 5. Or let's do it this way. This may not be clearly, my pen is giving problem. Okay, so we have to find this. Okay, so this is what 2 by 1, we know 2 by 1 to the power 5, and this is whole to the power minus 1. So the reciprocal of an exponential, we know that a by b, the reciprocal of the exponential a by b to the power m is nothing but b by a raised to the power m. So this will be 1 by 2 raised to the power 5, and this is nothing but 1 by 2 to the power 5, and this is 1 by 32. So 1 by 32 is the answer. Okay, 4. Part 4 is minus 5 raised to the power, how much is this? I can't see. Minus 5 raised to the power 6. Okay, so we have to find the reciprocal of this. The reciprocal of this is nothing but, we have to just take the reciprocal of the base. So that means 1 by minus 5 raised to the power 6. Now we see the base, the rational number, the denominator is negative, we have to make that positive. So this becomes minus 1 by 5 raised to the power 6. This is minus 1 to the power 6 divided by 5 to the power 6. Now minus 1 to the power 6 is 1 because the base is negative and the power, but the power is even. So this is 1 to the power 6, which is 1, and 5 to the power 6. How much is 5 to the power 6? It will be a big number. 125 is 5 cube. So it is 125 into 125. Anyway, I am leaving it like this, 1 by 5 to the power 6. So this is the answer. Okay. So that was question 1. Section A, question 1. Question 2 is by what number should we multiply minus 6 to the power minus 1? So we have, by what number we should multiply minus 1 to the power minus 1 to obtain the product 9 to the power minus 1. So we know how to solve this kind of problem. So we have to find if the number that we are asked to find is x. So we have minus x to the power minus 1 multiplied by x equals to 9 to the power minus 1. So from here this implies that x equals to 9 to the power minus 1 divided by minus 6 to the power minus 1. So we have to find this division. Now we know that when we divide to exponential, dividing the exponential means multiplying with the reciprocal of the divisor. Here the divisor is minus 6 to the power minus 1. So we will have to take its reciprocal. So to the power minus 1. Now this is 9 to the power minus 1 multiplied by this is minus 6 to the raised to the power minus 1 into minus 1. Why? Because we know that a by b raised to the power m again raised to the power n equals a by b raised to the power m into n. You know this. And also in the second step we know that any number, the reciprocal of any number, again we take a reciprocal, this is nothing but a. Okay, so this is now 9 to the power minus 1 multiplied by minus 6, because minus 1, the power minus 1 into minus 1 is 1. So minus 6 to the power 1 means minus 6, because anything to the power minus any number to the power 1 is always that number. So now this is reciprocal of 9 is 1 by 9 multiplied by minus 6. This is minus 6 by 9, and if we reduce it further we get 2 by minus 2 by 3. So this is the number, this is x, this is the number that we should multiply minus 5 to the power we should multiply minus 6 to the power minus 1 to get 9 to the power minus 1. So the answer is minus 2 by 3. Minus 2 by 3. Okay. Okay, so 2 is done. Let's see question number 3. 8:45. Question number 3. By what number should divided? By what number should minus 20 to the power minus 1 be divided? Let that number be x to get to obtain minus 10 to the power minus 1. So from here, so this is the mathematical problem statement or equation. We have to solve x from here. This implies we know that this is x equals to minus 20 to the power minus 1 divided by minus 10 to the power minus 1. Because we know that if we have an equation of the form a divided by x equals to b, where a and b are constant numbers and x is unknown, we have to find x. From here we know that x equals to a divided by b. Okay, so now we have to solve this. So we this is minus 20 to the power minus 1 and divided division by an exponential is nothing but multiplying with the reciprocal of the divisor. The reciprocal is 10 to the minus 10. It is a reciprocal, so we have to take its reciprocal again. So this is minus 20 to the power minus 1 multiplied by minus 10 raised to the power minus 1 multiplied by minus 1. So this is minus 20 raised to the power minus 1 multiplied by minus 10. And minus 20 to the power minus 1 means the reciprocal of minus 20, that is 1 by minus 20, and this is multiplied by minus 10. Now this is minus 10 by minus 20, and so minus minus cancels out. This is 1 by 2. So the number we have been asked to find is half. Okay, 3 is done. Let's see 4. Question number 4. Express, it has 2 parts. Express in standard form. So we have to express 2, how many zeros? 6 zeros. 1, 2, 3, 4, 5, 6 in standard form. Means we have to express this in the form k into 10 to the power n, where n is a natural number or positive integer. So what was the process I discussed? How do we convert a given large number in the standard form is that, so this is the given number. Step 1 is you put the step 1, if you follow my theory class where I expressed in the last theory class where I explained how do we express a large number in the standard form. There were a few steps. The first step was you put a decimal point after the first digit from the left, that is you put a decimal point after 2, and we have 3 zeros. Now you count the number of digits to the right of the decimal point. We have so the step 2 was actually to finding n. N is the number of digits you see in the number after the decimal point. So there are 6 zeros, so it will be n is 6. So now you have the number in standard form, something like this, 10 to the power 6. And the last step was you ignore all the zeros. You ignore all the zeros to the extreme right of the decimal part of the decimal number. Means you have to ignore all the zeros to the extreme right of in the decimal part. So if you ignore all the zeros, this becomes 2 multiplied by 10 to the power 6. This is the standard form. Okay. And this is fine, but you can also okay, this is fine. Express part 2. Part 2 is a number in standard form is given. It is asking to express in usual form. So the number given in standard form is 6.4 multiplied by 10 to the power 5. So this is the number in standard form. How do we convert it into the usual form? This is nothing but you just do the multiplication. You know how to multiply a decimal number with the powers of 10. I've already discussed this when we were doing multiplication of decimal numbers in the chapter decimals. So what we do is we shift, since it is 6.4 into 10 to the power 5, we shift the decimal point 5 digits to the right. So basically we have to, this is the number, and we have to make 5 jumps because it is 10 to the power 5. So we have to make 5 jumps. 1, 2, 3, 4, 5, and the last jump will be the position of the decimal point. And in between, if you don't have any digits, you just put 0 here, 0 here, 0 here, 0 here. So this becomes 6, 4, 0, 0, 0, 0 point. Now point, if after, so if you have nothing after the decimal point, it is assumed that there is a 0. So now if there is a single 0 after the decimal point, the only digit after decimal point is 0, you can ignore that. So the number in usual form becomes 6400 and 00, 64 zeros. This is the number in the usual form. Okay, this was part 2. 4 is done. Question number 5. It is asking to simplify 16 into 2 to the power n plus 1 minus 8 into 2 to the power n divided by 16 into 2 to the power n plus 2 minus 4 into 2 to the power n plus 1. Now, clearly we can understand that we have already done this kind of problem from the exercise while we were discussing the laws of exponents, and the simplification. We can see that it is in the rational form, and the numerator is the difference of two numbers where the two numbers have one factor as an exponential, that is 2 to the power n plus 1, 16 into 2 to the power n plus 1, 2 to the power n plus 1 is an exponential, and we have minus 8 into 2 to the power n. Now 2 to the power n plus, in the exponential, if you see, consider all the exponential, 2 to the power n is the smallest one. So we have to cancel that out. We can see that 2 to the power n is common in all the numbers. You see 4 numbers, right? I mean, if you consider these in the form a minus b divided by c minus d, then here also we have the factor 2 to the power n. Over here also we have the factor 2 to the power n. Over here also we have the factor 2 to the power n. Over here also we have the factor 2 to the power n. It will be clear if we rewrite this as 16 into, I know 2 to the power n plus 1 means 2 to the power n multiplied by 2 minus 8, this is 2 to the power n, fine, divided by 16 multiplied by 2 to the power n plus 2 means 2 to the power n multiplied by 2 square, because we know that a to the power m multiplied by a to the power n is a to the power m plus n, and if we have a number in the form a to the power m plus n, we can always break it down to a to the power m multiplied by a to the power n. So that's what I have done. I have broken the 2 to the power n plus 1 into 2 to the power n multiplied by 2. By 2 it is actually 1, and similarly I have broken 2 to the power n plus 1 into 2 factors, 2 to the power n multiplied by 2 square. Similarly this will become 4 into 2 to the power n multiplied by 2. Now I can take 2 to the power n from all these 4 numbers as common. If I get 2 to the power n common, I get 16 into 2 minus 8. From the denominator, if I take 2 to the power n common, I get 16 into 2 square minus 4 into 2. So 2 to the power n cancels out, and we are left with 32 minus 8 divided by 64 minus 8. This is this is 24 by 56. Okay, so this is, now if I cancel out with 4, this is 6 by 14. So it will again be reduced. 4, 6 and 4, 6. Okay, so this is 2, 3, 2, 7. So the answer is 3 by 7. This is the simplified value. Okay, 5 is done. 6 is the solving for unknown. 6 is it is given 2 to the power n minus 7 multiplied by 5 into 5 raised to the power n minus 4 equals 1, 2, 5, 0. Then find n. Now clearly we see that the left hand side is a product of two exponential. It is the first one is 2 raised to the power something, and the second one is 5 raised to the power something, and the right hand side is a number. So clearly we have to express 1, 2, 5, 0 as product of powers of 2 and powers of 5. So let's factorize 1, 2, 5, 0. Let's start with 2. So 2, 6, 25. Now we divide by 5. This is 1, 25, again 5, this is 25, again 5, 5 and 5. So we can see that 1250 can be the prime factorization of 1250 is, we have 1 2, that is 2 to the power 2 to the power 1 multiplied by 5 to the power 4, because we have 4 5s, 5 to the power 4. So now from here we can clearly equate the powers of 2 from both sides or the powers of 5. Let's say we are equating the powers of 2 on both sides. So this will imply, if we equate the powers of 2 from both sides, this will imply n minus 7 equals 1. This implies n equals 1 plus 7 equals 8. And if you equate the powers of 5, that also will lead to the solution n equals to 8. So n equals to 8 is the solution. Okay. Let's do section B. These are mark against the correct answer in each of the following. So these are MCQ. These are MCQ questions. Okay, mark against the correct answer. Okay, so the first one is 7 is 3 by 4. It is given how much is 3 by 4 to the power 0, and we know that any non-zero number when raised to the power 0 is always 1. So 1 is the result. So the answer will be choice 7 is C. Okay, 7 is done. Question number 8. It is asking the value of minus 3 by 4 raised to the power minus 3. Okay, we have to see the options. So the options are given in as rational numbers. Okay, so this is a power is a negative integer. So we know that the concept, we know that a by b when raised to the power a negative integer minus m, this is nothing but the reciprocal of the base raised to the power m. So this will be the reciprocal of base, that is 4 by minus 3 raised to the power 3. So now the reciprocal, the base is 4 by minus 3. We have to convert that into standard form, the rational number, which becomes minus 4 by 3 to the power 3. And now if we break it down, if we express it as a rational number, this will be minus 4 to the power 3 and 3 to the power 3. Now minus 4 to the power 3, the base is negative and the power is odd. So this becomes negative of 4 to the power 3, and this is 3 to the power 3. This is minus 64 by 27. So minus 64 by 27 is the result, and the answer is choice D. Okay, 8 is done. 9. Question number 9 is minus 5 by 3 raised to the power minus 1. This is simple. This is power is minus 1, which means reciprocal. So this is nothing but the reciprocal of minus 5 by 3 is 3 by minus 5, and we know that we have to, this is the rational number is not in standard form because we have a negative denominator. We have to make the denominator positive. So this becomes minus 3 by 5 is the result, and the choice is question number 9, minus 3 by 5 is B. Okay. Question number 10. It is asking to simplify 1 by 3 to the power, let's increase the font, I can't see it properly. Okay, 1 by 3 raised to the power minus 3 divided by minus 2 by 3 raised to the power 10, sorry. Okay, 10. 1 by 3 raised to the power minus 3 minus half raised to the power minus 3. Okay, this is, we have to simplify. Now we know that anything if the power is negative integer, it will be, so this is nothing but the reciprocal of 1 by 3, that is 3 raised to the power 3 minus half raised to the power minus 3 means the reciprocal of 1 by 2, that is 2 raised to the power 3. This is 27 minus 8, this is 19. 27 minus 8, 19. So the answer is A. Okay, question 10 is done. I have no idea, I don't think the timer is working properly. Anyway, 11. Question 11. It is minus 2 by 3 to the power 10 divided by minus 2 by 3 whole to the power 8. We have to simplify this. Okay, so first we see that it is a division of two exponential where both the base are same, that is minus 2 by 3. Okay, so now we know that we know this law that a by b raised to the power m divided by a by b raised to the power n equals a by b raised to the power m minus n if m is greater than n, and in this case we see m is 10 and n is 8, so 10 is greater than 8. So as per the formula laws, this becomes minus 2 by 3 raised to the power 10 minus 8. So this is minus 2 by 3 raised to the power 2, and this is minus 2 raised to the power 2 divided by 3 square. Now minus 2 square, minus 2 raised to the power 2 is 2 square, because the power is even though the base is negative, the power is even, so it will be a positive. So this is 2 square by 3 square, this is 4 by 9. So 4 by 9 is the result, and so the answer is A. Answer is choice A. Okay, let's do question number 12. Which of the following numbers is in standard form? Okay, it is asking which of the numbers. A is 9 multiplied by 3 to the power n. Sorry, what I'm doing. A is 32.63 into 10 to the power 4. This is not in standard form because this is wrong. This is wrong, as we know the standard form is k. The standard form of a large number is in the form k multiplied by 10 to the power n, where n is a positive integer but k is greater than or equals to 1 but less than 10. K must be less than 10 and greater than or equals to 1. So A is not in standard form because k over here is greater than 10. B is 326.3 multiplied by 10 to the power 3. This is again wrong because this part is wrong. This should be less than 10 and greater than or equals to 1. What is C? C is 3.263 multiplied by 10 to the power 5. This is absolutely right because over here k is 3.2, which is greater than or equals to 1 and less than 10. So okay, so A and B are not in standard form but C is in standard form. Okay. Section C, question number 13. Fill in the blanks. Fill in the blanks. Part 1 is, it says, if n multiplied by 3 to the power n equals to 3 to the power 6, then what is n equals to dash? We have to find n. So from the equation 9 into 3 to the power n equals to 3 to the power 6, in this kind of, this is a problem of solving unknown power. So we have discussed, we have solved this kind of problems earlier. We know that we have to convert the equation in the form so that on both sides we have exponential, and either the base will be same or the powers will be same. If the base are same, then we will equate the powers, and if the powers are same, we will equate the base. So the left hand side can be written as 9 can be written as 3 square, because we have to convert on the right hand side of the equation. We have the base is 3 and the power is 6. Base is 3, so we have to convert the left hand side to an exponential form where the base will be 3. So 3 square multiplied by 3 to the power n equals to 3 to the power 6. This implies we have the base 2 exponential where the base are same 3. So this becomes 3 to the power 2 plus n equals to 3 to the power 6. Now we see we have 2 exponential are being equated and the base are same. So we can say that the powers will be same. So 2 plus n equals to 6. This implies n equals to 6 minus 2 equals to 4. So n equals to 4 is the answer. N equals to 4. Okay. Part 1 done, 13. Let's see. It's happening. Part 2. It is saying 8 to the power 0. This is absolutely easy. 8 to the any number, non-zero number to the power 0 is always 1. Okay. And 3, it says a by b raised to the power minus 16 equals a by b raised to the power minus 16 equals, I mean, we don't know the value of a and b, so definitely it will not be, this will not lead to any constant number, fixed number. It will surely be in terms of a and b. At the best, what we can see, we can make the power positive. We can see that the exponent is minus 16. So we can say that this is nothing but b by a raised to the power 16. Because we know that we have, from the laws of exponents, we know that a by b raised to the power minus m equals b by a raised to the power m. We know this. Okay. And part 4 is minus 2 raised to the power minus 5. We have to find the value of this. Now this equals, we know that any exponent, any exponential number where the exponent is a negative integer, it will be the reciprocal of the base. That the reciprocal of the base will be 1 by minus 2, and the power is the numerical value, that is 5. Now this is the base is 1 by minus 2. We have to make it in standard form. The rational number 1 by minus 2 is not in standard form. We have to make the denominator positive. So this will become minus 1 by 2 to the power 5, and this is nothing but minus 1 to the power 5 divided by 2 to the power 5. This is minus 1 to the power 5 is minus 1, because minus 1 to the power 5 is actually negative of 1 to the power 5, because the power is an odd integer and the base is negative, and 2 to the power 5 is how much? 32. So this is minus 1 by 32. So the answer is minus 1 by 32. So C is done, and we are left with section D. Okay, these are true false statements. The first one says that 645 in standard form is 6.45 multiplied by 10 square. So let's first see what is the standard form of 645. So we know how to find the standard form. We first put the decimal point after the first digit from the left hand side. So this becomes 6.45. Okay, and then we put a 10 to the power, we multiply it with 10 to the power n, where n will be the number of digits to the right of the decimal point. So we have 4 and 5, 2 digits, so 10 square. So actually in the standard form 645 should be 6.45 into 10 square, but it is given that, yeah, it is given 6.45 into 10 square. So this is 645 is indeed in standard form 6.45 into 10 square. This is a true statement. Okay. Part 2 is 2700. 27000 in standard form is, let's see what is the standard form of 27000. So first we put the decimal point after the first digit from the left hand side. So this become 2.7000, and then we multiply it with 10 to the power n, where n will be the number of digits to the right hand side of the decimal point, and we have 4 digits, that is 7000. So this becomes 10 to the power 4. 10 to the power 4. So now we can ignore the rightmost zeros in the decimal part. This becomes 2.7 multiplied by 10 to the power 4, but it is given that the standard form is 27 multiplied by 10 cube. This is false, because in standard form we know that k is less than 10 and greater than or equals to 1. So this is the correct form in standard form, but this is given. This is wrong. So this statement is false. Okay, let's see part 3. What is part 3? Okay, it is saying that 3 to the power 0 plus 4 to the power 0 plus 5 to the power 0 is equals to 12. No, this is false, because we know that this is nothing but any number, non-zero number raised to the power 0 is always 1. So this is 1 plus 1 plus 1 equals 3, and this is definitely not equals to 12. This is a false statement. Okay, what is 4? 4 is saying that reciprocal of 5 raised to the power 6. It is saying that reciprocal of 5 raised to the power 6 is equals to 6 to the power 5. No, this is absolutely wrong, because we know that the reciprocal of 5 raised to the power 6 is 5. This is 5 raised to the power minus 6, because we know that a raised to the power m and again raised to the power n is nothing but a raised to the power m into n. So over here we are given the reciprocal of 5 to the power 6 is nothing but 5 to the power 6, again whole, that whole is again raised to the power minus 1. Now if we multiply 6 and minus 1, it is minus 6. This is minus 6, and we know that this is 1 by 5 raised to the power 6. So this is definitely not equals to 6 to the power 5. The concept applied, I am writing on the right hand side that 5 raised to the power minus 6 is equals to 1 by 5 raised to the power 6 is coming from the fact that a by b raised to the power minus m equals b by a raised to the power m. This we have learned in the laws of exponents. Okay, so this is false. What is 5? Part 5 says, do we have any question? No, this is the last one. So 5 says that if if 5 reciprocal of 5 multiplied by x equals to reciprocal of 8, then x is, then it is given that then x is equals to 8 by 5. Let's see, this is given, reciprocal of 5 multiplied by x equals to 8 reciprocal of 8. So from here we can say that x equals to 8 reciprocal of 8 divided by reciprocal of minus reciprocal of 5. How we know that? Sorry, from the fact, from the concept that a multiplied by x equals to b is given, where a and b are constant and x is unknown. From here we know that x equals to b divided by a. So we have x equals to a reciprocal of 8 divided by reciprocal of 5, and this is nothing but 8 reciprocal multiplied by the reciprocal. Here the divisor is, we know that a divided by b is equals to a multiplied by the reciprocal of b, which is nothing but b to the power minus 1. So we can say this is multiplied by 5, it is already reciprocal of 5, again raised to the power minus 1. So this is 8 raised to the power minus 1 multiplied by 5. Why? Because the powers minus 1 and minus 1 will get multiplied, and minus 1 into minus 1 is 1. So this is 5 to the power 1, which is 5. Now this is 5, 8 to the power minus 1 means reciprocal of 8, that is 5 by 8. And 5 by 8 is definitely not equals to 8 by 5. So this is a false statement. Okay, that brings to the end of solving the test paper 5. I don't know how many questions I did it correctly because I don't know the answer. I hope solving this paper will be beneficial to you in understanding how we are applying the concepts of exponents to solve the variety of problem that has been covered in the textbook of author R.S. Aggarwal. So thanks for watching, and until the next video, take care and bye.